Hi Kim Peeps. This is video 2 on solubility curves, and we're going to do some practice. You can see on the left side of the screen I have a general solubility curve with many solutes that we're going to be studying. The y-axis is the amount of grams of the solute in 100 grams of water, and the x-axis is the temperature. So we're just going to go down through the questions on the right side and answer them together. And hopefully this will help you understand how to read a solubility curve for different things that you're doing in chemistry. So in question 6, it says, how many grams of ammonium chloride, NH4Cl, is at 50 degrees Celsius? So we're going to come here down on the x-axis at 50. We're going to come up this line to the point where we hit the NH4Cl, and then we're going to go across to the y-axis, and we can see that 50 grams of ammonium chloride is dissolved. In question 7, it says, which two substances have the same solubility at approximately 78 degrees? So we're approximately here on the x-axis. We're going to come up until we see where two different substances cross, and right here we see that there is an intersection between potassium chlorate and ammonium chloride, or table salt, sodium chloride. So just looking here real quick. Yeah, I was just saying my sheet said something else, and I don't think that was right. So we're just going to go with what I found here. Okay, so the next question says, which compound is the least soluble at 10 degrees? So 10 degrees puts us right here. The first line that we come across is this one, which happens to be the potassium chlorate. So we're going to say that this one is the least soluble at 10 degrees. Question 9 says, how many grams of potassium nitrate can be dissolved at 50 degrees Celsius? So again, we're at 50 degrees, and we're going to come up to the potassium nitrate, which is this substance right here. So if we come up, we're about right here. It's going to be about 80 to 85 grams. Question 10 says, are the following substances considered saturated, supersaturated, or unsaturated? Well, let's just erase some stuff that we have on here, and let's look at where we're at, where we have 45 grams of sodium nitrate, which is this substance here, at 30 degrees. So if we come up to this line where it intersects and then come over, it's going to be about 95 grams. Oh, I'm sorry. It's asking me 45. So right here on the line, it is 95. 45 is way down here, so it's way under, so that's not the answer. It's unsaturated, meaning that the point that they're looking at is below the saturated line, therefore it's unsaturated. If we look at the next one, we have 60 grams of potassium chlorate and 100 grams of water at 60 degrees. So 60 degrees, and we're going to come up to the potassium chlorate, which is right here. And we have 60 grams. Well, this on the line is approximately 24 to 23 grams, but we're going to be at 60, which is way above the line. So this is going to be super saturated. Okay. All right. So let's go to the next question. 11 says, how many grams of sodium chloride are required to saturate 100 grams of water at 100 degrees? So we're at 100 degrees, and we're in 100 grams of water, so that's good. And we want to know how many grams. So if we come up, right here is the sodium chloride. If we go across, it's approximately 40 grams. All right, 12. How many grams of sodium nitrate are required to saturate 100 grams of water at 90 degrees? So we're at 90 degrees. I'm going to change my pen color. I should erase everything, which we will clear here soon. And we're going to go up to sodium nitrate, which is this substance here. So if I come up, it's going to be up here. And it is going to be about 150 grams. So it's about as high as it goes there. Okay. 13, how many grams of potassium iodide will saturate at 20 degrees Celsius? So here's potassium iodide. 20 degrees is here. We're going to come up, and we're at this point right here, and it's about 148. Okay, so question 14. At what temperature would 25 grams of potassium chlorate dissolve? So I'm going to clear this because we're kind of shifting gears on how we're doing these problems. So let's just kind of shift our gears. I'm going to go to blue, I think. Okay, so we want to know 25 grams of potassium chlorate. So potassium chlorate is this substance here. We're at 25 degrees. We're going to come up here. It's actually intersecting there. And nope, we want temperature, not 25 grams. We want 25 grams, which is going to be right here. We're going to come across till we hit this point. We're going to drop down. It's about 58 degrees Celsius. Okay, 15. I guess we're on 15. At what temperature would 55 grams of ammonium chloride? So ammonium chloride's here. We have 55 grams, which is right here. So we're going to come across until we hit the line and then come down. And it's about 60 degrees. All right, 16. 89 grams of sodium nitrate is prepared at 30 degrees. Will all the salt dissolve? All right, so let's just change our color here. 89 grams. So we are about here. And we want to go up to the sodium nitrate, which is this. So I'm going to come up here. And it says it has 89 grams and it is right on the line. So yes, it's saturated. It's all going to dissolve. What mass of sodium nitrate will dissolve at this temperature? Well, if we come across to here, it's going to be 148 grams. Ugh, that does not look legible. Let's fix that. Okay, question 17. If 25 grams of ammonium chloride is dissolved at 50 degrees, how many additional grams of sodium chloride would be needed to dissolve at 80 degrees? So if we look at, I'm going to clear my screen here real quick. So we have 25 grams. So 25 grams is right about there of the ammonium chloride, which is this substance here. Is dissolved at 50 degrees. Let's see, if 25 grams is dissolved at 50 degrees, how many additional would be needed? So when we have a saturated solution right here on this line, if we come across, we have about 50 grams that dissolves at 50 degrees. And if we've only dissolved 25, the difference would be, oh, I'm sorry, I read that wrong. So if 25 grams is dissolved at 50 degrees, how many additional grams would be able to be needed at a saturated solution at 80 degrees? So if we come over here to 80 degrees and come up to this line at 80 degrees, let's see here, we can fit about 64 grams at 80 degrees, but we already have 25 grams in the solution. So that means that we're going to have 9 and 2 from 5, 39 more grams that we can dissolve in that solution. Okay, 18. At 50 degrees Celsius, how many grams of KNO3 will dissolve? So let's clear the screen. So at 50 degrees, how many grams of KNO3? So here's KNO3. Will dissolve. So if we come up and hit that line there and go across, it's going to be about 80 grams. At 70 degrees Celsius, how many grams of the cerium sulfate, which is right here, will dissolve? So at 70 degrees right here, not very much. It actually, with temperature, it has a decreasing solubility. So it's going to be about 5 grams. Okay, 20. Determine if each of the following is saturated, supersaturated, or unsaturated. So let's go ahead. I'm going to change to red, I think, for this so that we can see better where the point is. So we have 55 grams of the ammonia. So here's the ammonia. And we're at 20 degrees. So if we come up, we have 55. And at 20 degrees, 55 is going to be more. So this is going to be super saturated. And then we have the cerium sulfate. We have 10 grams at 10 degrees. 10 degrees, point here. Oops, our point is here. We usually have 5. Again, this is going to be a super saturated solution because 10 grams is more than what's at a saturated point. Then we have the KNO3, which is 60 degrees Celsius. So if we come up and hit the 60 degrees point, it's right here. And then if we come across, we're a little above 100. So 125 grams would also be supersaturated. Okay, then we have 80 degrees of the ammonium chloride, which is right here. If we come up, the saturated solution is at about 65 degrees, and that's exactly how much they're putting in. So this is saturated because it's right on the line. Then we have the ammonia. Okay, so here we're at the ammonia again. And we're at 90 degrees. So if I come up and hit the ammonia line, it's not very far. It's right there. And I have 12. Well, I can only fit 10 in at 90, so this is going to be super saturated. Let's just erase real quickly. We're almost done here, but I want to be able to see what I'm doing. All right, it says we have 80 grams of ammonium nitrate. So here's the ammonium nitrate. And at 10 degrees, so if I come up, it's right here. And that's about 80 grams. 80 grams, that's exactly the same. So this is saturated. And then we have 80 degrees of ammonium nitrate. Again, we're going to come up. I'm trying to right here. Of sodium nitrate, sorry. 80 degrees, 145. That is exactly right on the line. So this is saturated. And then finally, we have 100 degrees of the sodium chloride, which is going to be right here. And we're going to put in 35 grams. Now, 35 grams is a little bit below where that's at. So this is going to be an unsaturated solution. Okay, so that's how you read a solubility curve and find out different values that you need for a solution and its solubility. I hope this helped. You can find more on solutions on Chem's Chem Chat on both YouTube and TikTok. Leave me a like, leave me a comment, and I'll see you on the next video.